So, hi everyone. Today again we are here with a new problem of DSA. Today the problem is path sum. This is problem number 112 in of LeetCode. So, the problem is of binary tree. So, here is the description of problem. Given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such as that adding up of all the values the path equal to target sum. A leaf node with no children. So let us understand the problem and also the approach that how we're going to solve this problem. So came with here an example. So suppose this is the given tree and the target sum is 19. So what we have to do, we just have to find the path where summing from this root node to leaf node. Means if the summation of every node from root to leaf node equals to this target sum, then we will return true. And if in the whole tree we don't find any of the path which is equals to this target sum, then we will return false. So suppose in this tree we can check that 1 plus 2 plus 7 plus 9 equals to target sum 19. So this is the right path, and in that case we will return true. And suppose if we got sum like 7. So if target sum in place of this 19, if target sum equals to 7, then we can check, we can see that there is no element like 4 plus 3 equals to 7, like 1 plus 3. So there is no way that that we do summation from root node to leaf node and the summation becomes equals to this target sum. So in that case we will return false. I hope that the question is clear to you all. So now we will check the approach. We will discuss about the approach that we will going to implement. So let's start. We use recursion over here, and in tree vision most of the time we use recursion. So what we will do that every time we move to next node, we just reduce the target value by subtracting that value. So suppose we start traversing from here. So I'm taking another, let's say, okay. So suppose I start traversing from this root node. So as I start traversing from here, so I will subtract this value from target. So after subtracting it, the target will become 18. And I will move as it is recursion. So first I will go to left side. Now at this point again I will subtract this value, and after every call we check that if the root dot value means if we are at this root, then we check that if it is a leaf node or not. So the how we can find that this is the leaf node? If it has none, or we say null on the left side and also on the right side, then it is the leaf node. So after subtracting 1, it will become 18. Now at over here we will subtract 2, so it will become 16 over here. Now again we will go on. So we can see over here that at this point this is the leaf node, as it has no left child and also it has no right child. So this is the leaf node, and after subtracting this 6 from this 16, so it will, because for this 6 the target value is 16, so it will become 10. Okay, but at this point it have to be 0 for returning true, but it is not. So in recursion we will go back one, We go for going back. I'm using this another color. So we are going back again over here, and from here we will go on right side. So from this point, and at this point, since the target is 16, so it will be 16. Now we came over here, and again we subtract this 7. So 16 minus 7, it will become 9. Now for this 9, the target is 9. So as we go over here, so 9 minus 9 equals to 0. Now we can see that it is the leaf node because it has no left child and also no right child. So this is the leaf node, and also the target value gets 0 over here. Means this is the right part that we are searching for. So as soon as we got this 0, we will return true. From here only we will return true, and finally as it is recursion, it goes to 7, 2, and as soon as it reaches over here, it finally returns the true. Now we don't need to go on the right side. If we get, suppose if we don't get this target value over here, suppose the target is something else, then we definitely go on right side also. So similar things happen with, let me take another one. So if suppose we don't get our target sum on the left side, then we will go on right side as similar way that we are going on over here. So we go to over here, and it's the same thing. Now the target value becomes 18 because over here the target was 18 after subtracting 1. So it will go over here and again subtracts this value, then it will go on left side just following the same path of recursion, and again go over here, and finally it goes over here. If at any point it gets like if we got our summation equals to this target value at 5, then the same thing happen, it returns true at the same point. And suppose we got summation equals to target value equals to 0 over here, then we will return true over here. But suppose if we traverse this also and we have not got true over here also, then finally in recursion it will go to 3, then it will go to 1, and finally over here we have not got the summation equals to this target value, and at that point after the whole recursion we will return false. So I hope that the approach is clear to you all. Now we will implement this approach in our code. So so since we are going to check true false as an answer, so I will take answer. Sorry, let me check. Answer equals to false. Initially it is false, and if the condition gets satisfied, we will make this answer as true. Now we will check that if root equals to none, then we will simply return none, or we will return 0 also. It will not affect the answer. So now we have to decide the next target, that what will be the next target. So I'm giving this as, let's take sm equals to, since it will going to our next target, then target sum minus root dot val, because the next target will be what? The next target will be decided after subtracting this root value. So initially the target is 19, so we had subtracted this 1 and it will become 18 as target for this too. So we are just doing the same. So we have got our next target and also the condition for checking. Now we will check the condition that if sm equals to 0 and at the point it gets 0, this that is the root node, then we will simply return true. And root dot left equals to none, and okay, sorry, I have to put and over here also, and the root dot right equals to none. So this is the condition for checking leaf node, and this is the condition for our target if target becomes 0. As we are going to update it, it will become clear to you all. So we will return true. And suppose if the target if this sm not gets 0 after subtracting root dot value from target, then we will just call the traversal. Sorry, we will just call the recursive. We will make a recursive call. So we will check that if root dot left not equals to none, and if you don't put it, then also it will work fine. If root dot left not equals to none, then we will make a recursive call. Since we are storing the answer in this answer, initially it is false, so the final answer will come in this answer variable equals to answer, or now we will call this function or method self dot has path sum, and what we pass over here, root dot left, root dot left comma sm. Since sm is our new target, after subtracting the root value at the point which we are, suppose we are at 4, so we will subtract this 4 from target value, and this will become the new target if it is not equals to 0. If it is equals to 0, then we will simply return true over here, and if it is not, then it will go as our new target. Now we will make a check over here that if the answer becomes true, then we will simply return true from here only. If answer equals to true, then we will return true from here only. No need to check it for right side. Now if root dot right not equals to none, then answer equals to answer or self dot h path sum. Now we are calling the right tree, or in this method we are passing the right tree or the right path, right comma sm, since sm is one new target, and finally we will return the answer, return Now suppose it will check that if it gets true over here. If it is not, then the control goes on right side, and it will check for the answer on the right side, and finally it returns true. Then what the value that will become in final call, then it will return the answer. The same thing is stored in that answer. We have passed, we have used or in place of and, because suppose initially we get answer as false, and in any call, like it's a recursion call, so finally, like suppose we got 5 plus 8 plus 13 as our target sum, final target sum, then it returns true from here. And as we have used or, so it so false or true becomes true. So answer is to stores true at this point, and finally it returns the true. Okay, now let's run this code. Okay, there is one error. Let's check that. What is the error? Okay, I put one extra equal sign. Okay, so it runs sample test gets passed. So let's submit. Okay, now it was completely fine. This shows that the logic is correct. So this is our solution. We can omit this condition over here. Like if we don't write this, like if we don't check this, then also it works completely fine. If you, now it's up to you that whether you want to check that answer equals to true at this point or not. It's totally up to you. You can use if condition over here, and you can use if condition over here also. Okay, then now up till now we have seen the Python solution over here. Now we will go for C++ solution. So the one thing that you have seen in C++ solution, that the approach is all approximate, exactly same that we did in the same thing that we did in Python. We are doing the same thing over here, but you can see over here that, as I said, that the two if condition in if root dot left not equals to null, then we call that ans equals to ans, or the recursive call. And after that we check that if ans equals to true, then we simply returns true. Okay, but suppose like we have, as I said in Python solution, that it is totally up to us that whether we want to use these if condition inside this if or not. It's totally up to you. If you omit these two ifs, then also the solution works completely fine. If you put this condition over, then it will somewhat reduces the time complexity. The solution gets better. That's why I use over here. Use these two if extra if over here, and in Python I had not, just to show that in both the cases it will work fine. And rest of the things you can see over here, the solution is same exactly that that of Python, and also that the logic that we have discussed over here. So everything is same. So you can visualize it. Same we have taken int as equals to target sum minus root dot 12. There is just the change in syntax and nothing else. So let's run this code also. Is it working fine? Yeah, it is working fine. Let's submit it also. So you can see over here that the solution works fine. This code is correct. So thank you for viewing. We will come again with a new problem of PSA. Till then, keep on practicing. Thank you.